Alright, in this video we're going to look at how we can apply a transformation to a set of data and then calculate the sum of residual squared value. So what I've got here is just two variables, so hours studied and the number of questions incorrect. We've got all of our values. That doesn't really concern you too much, but we're going to do some linear regression on this. So if I have a look at the scatter plot, which I've got here, we get that nice nonlinear shape. So I refer to my circle of transformations and I can apply those transformations. I can do log or reciprocal of either my x or my y variables. Here we're going to focus on doing our reciprocal of the y variables and the log of the y variables, because when we transform our response variables, that's where we run into some issues with calculating the sum of residual squares. So what I'm going to do is set up some variables now. I'm going to have my explanatory and my response variable, so EV and RV. My explanatory variable we're not going to touch, so that's just going to be our hours studied. And then for my response variable, we could do either log or reciprocal. I'm going to do a log first. So let's go log of my response variable, which was incorrect questions. So we get that. We could then do our linear regression, so menu, statistics, stat calculations. We're going to do a linear regression, and we're going to do it on our explanatory and our response variable. So that's the beauty of doing this, that whatever I do now for my explanatory and response variable, the linear regression is automatically going to calculate. Saving my regression equation as F1, that's going to be important. So we're actually saving that equation that we'll then use, and then everything else follows through the same. So I've got my regression equation. So when we write this, just make sure that we do it in terms of log of our incorrect questions. If I have a look at my scatter plot, what I'm going to do is I'm just going to change that to my response variable. So notice something becomes a lot more linear. I'll change it to my explanatory variable. Doesn't really change, as expected. I'm going to add in my regression line. So menu, analyze, regression, and we're going to go show linear a plus bx, because that's what we've been doing. So I get my beautiful regression line, see how close it is to all my data points. Usually if I wanted to get my sum of residual squared values, what I need to do is I need to go menu, analyze, and then down to residuals, which is suddenly available now. Before it was grayed out, before I did my regression line, now it's there. For residuals, we're going to go show residual squares. And what that does is it takes all of our residuals, so the vertical distance between my data point and our line, takes that as a side length of a square, finds all the areas of the squares, and it comes up with that sum of squares value. Now, if I compare it with the linear data, so if I just change that back to incorrect, you can see I've got a sum of squares of about 753. So quite a lot of error. We can see that first one produces a big old residual. As I change that to my response variable, that comes down to 0.04. So you might go, awesome, so much less error. But again, because we've transformed our response variable, it's actually calculated the sum of squares in a really funny way. So what we need to do is actually do it manually. So to do it manually, we're going to go back to our list spreadsheet, and we're going to use the equation that the calculator has saved. So again, if I show you, it's going to be saved as F1. I want to use that equation to help make our predictions. So my predictions, I want to take F1 of my explanatory variable, which was our hours studied. So that is taking the number of hours studied and substituting it into my regression equation. So if I hit enter on that, it gives me all this. Now 1.68 still doesn't sound right because my original value was 63. And that is because we have applied that transformation. So this 1.68 is actually got that log applied to it. So I need to undo that log. So how we undo a log is by raising that number as a power with a base of 10. So if I go back to my equation, I'm going to change that as 10 to the power of that number. I just need to copy and paste that in. So it's now 10 to the power of whatever that prediction is. Yep, I'm going to overwrite it. So now, my numbers make a little bit more sense now. So I've got 26.29 compared to 23. So pretty good. There's my predictions. I want to work out my residuals in this column. So residual. So my residual is my actual value. So the actual incorrect minus my predicted value. So get all that. And then finally, my sum of squares will be the square of each of these added up. So just in any random cell next to it, I can go equals sum. That's going to add them up. And then take my residuals and then square that value. So as I hit enter, I now get 256, 257. Compare that to my original one. If I change that back to incorrect of 753, now we've got 257. So much better value. So that's how we can calculate our sum of residual squares when I've transformed my y variable or my response variable. A few processes, but we get into the habit of it and we can do it quickly. Thanks for watching, and we'll see you all next time.